Hi everyone. My name is Joanna, and the goal of my today's presentation is for you to not dread the word ML and unit tests in one sentence the next time you hear about that. But before that, I would like to introduce myself. So as I said, my name is Joanna. I work as a data scientist at CK Delta, and we focus on ML use cases in utilities in our company. And I'm interested in ML ops, and I'm a strong believer that the best practices in coding should also apply to data scientists and machine learning engineers, because yeah, this is how it is. This is coding, so yeah, it makes sense. Okay, and today I would like to focus on one component of clean code, which is unit tests. So we're going to start with a short recap what exactly are unit tests, and then we'll move to a more philosophical questions why data scientists should test their code, and then we'll wrap up with a demo of how to actually write unit tests for machine learning code. So let's start with the main question. What exactly are unit tests? So there are three things about unit tests that you need to remember. So first thing is that unit tests validate small pieces of code, which are called units. So they focus on detail rather than the whole picture. And they treat separate functions and functionalities as totally separate components of a larger program. So they don't view it as a process of a whole working program, but rather as a combination of individual pieces. And this actually relates to the third feature, which is unit tests work in isolation. So they don't depend on any external libraries, but also they don't depend on any other piece of your code. And there's the first principle, which applies to unit tests. And this is an acronym for the most important features of unit tests. So unit tests should be fast, just because you want to test your code as often as possible when you in the development process. So it's better to write tests in the way that make them fast and repeatable. And the next important thing is being independent, meaning that they work in isolation and they're independent from external libraries, but also other parts of your code. And the next feature is repeatable, and it means that unit tests should work exactly the same in all of the environments that you have. So the expected output should be exactly the same, whichever environment you choose. The next feature, self-validating, isn't that self-explanatory, but it means that unit tests should have two scenarios. So they could either fail or pass. There is no other logic than that. They should only have one of those two options. And finally, timely, meaning that unit tests should be written in an appropriate moment in a project. So before actually producing a production code. So we want to make sure that before we put anything into production, the code is tested and reliable. But you may say, okay, like production code and a development cycle, this all applies to software engineers, and how does it apply to data scientists? Because data scientists care about models, predictions, and how does it apply to them? I believe you can't really distinguish those two parts. So clean code and predictions are kind of integrated together. Because data scientists work with large amounts of data and they use complex algorithms, their code is even more prone to mistakes than usual Python code. And in order to be sure that our predictions are reliable and accurate, it's even more essential to unit test our code. And because those predictions are often used for some important business decisions, it's very critical to to make sure that our code is reliable and accurate. Okay. So now we talked a little bit about unit tests in general, but let's see how they work in action and how we could apply it to a real-life case. So imagine you are a data scientist and you have a new client. And this client is an owner of a sustainable shop. And he noticed that each week a lot of fresh products, such as dairy, veggies, go to waste, probably because he ordered too many of some items, or maybe they're not advertised enough. And he needs your help to find out which products will go to waste in the nearest future. And because you're a data scientist, you know that you need to train a model, generate predictions, and you're ready to do that. But let's see the functions before actually generating the predictions. Okay. Okay, so we have prepared 3 functions, and one function is for data cleaning, one is for data preprocessing, and one is for training and predicting. And this is usually how machine learning pipelines look like. They all include those 3 steps, and all of those 3 steps should be unit tested at some point. So let's look at the first function, which is clean in. And the purpose of this function is to clean the column which contains EN numbers and remove the ones that are invalid. Because we want to predict which products will go to waste and which not, it's essential to identify those products. And this is done using this column. So the cleaning process consists of a couple of steps. So we're removing the leading zeros from the beginning, and then we're checking if all of the remaining characters are numeric and if the string is the length of the string is equal to 13. And if not, this invalid EN is replaced by a missing value. Okay, so let's go to the test and start writing one. So first thing that should be in the test is all of the scenarios that we want to test. So, So before writing a test, we need to answer 2 questions. So first is, what do we really want to accomplish in this function? So in this case, we want a clean column with clean EN numbers. And what we want to test are at least those 4 different scenarios that we described. So let's create a column. Which will contain several different numbers. So we saw in the function that the first thing that it does is removing zeros and then checking if numeric, and then length of the string. So we need a couple of examples that kind of match those constraints. So first, let's put.
Can people see the screen? If you can't, can you increase the font size?
Yeah.
Just shout when you can see this font. Can see it.
Command plus.
Okay.
Still see or not see? Okay.
Okay.
Thanks.
Okay, so let's first consider the best possible scenario. So we have an EN number that's exactly 13 characters, and all of them are numeric. So it could be like something like this. Okay. And then let's add a different example that should be clean. So we saw that we're removing the leading zero, so let's try something with that. So we could actually copy the same number and add a couple of zeros at the beginning. So we expect those zeros to be deleted and to get the EN number just containing the rest of the numbers. So these are the positive scenarios. So we know that those will not be replaced by the missing values, and they would just be cleaned. So let's test also a couple of negative scenarios, so the ones that will be replaced with missing values. So it could be either a too short string or a string containing a non-numerical value. And do you have any suggestions what we could also test that we want to test, like a number or something else? Kittens, okay. Yeah, let's see kittens. Okay, we can also test, I don't know, none to see if this works. Okay, so we have our scenarios prepared, and then we need to call our function. So PyLadies, where we pass our series. Okay, and the last part is actually coding the assertion. So all of the expected outputs that we want to get from this test. So in this case, we predict that the first two are going to be cleaned, and they will be exactly the same because we just removed the leading zeros. So we can do something like assert PyLadies and use this string. And the second one will be exactly the same because of those zeros. And we kind of expect for the rest to be replaced with missing values. So we want to test that as well. Okay. Okay, so we have our test ready, and now we could actually run it to see if this works. We can use this dash K to specify the particular test that we want to run now. Okay, this is weird. Okay, so now we see that all of the tests have passed. So we just made sure that our cleaning function worked as expected. And there are a couple of things about this test that I would like to add as well. So tests are functions as any other, so they should follow the same best practices that we use for regular functions. So the naming conventions and the number of functionalities in a single function should also be the same as with normal functions. It is also a good practice to include as little assertions as possible in a test. So if you have a very complex function with raising a lot of errors and stuff like that, it's better to divide it into separate functions. So in our case, it would probably be better to write a parameterized test and not write all of the different assertions inside the function. Why this is important also is that tests could have the documentation function. So if a new data scientist comes into your team and he doesn't really know how your code works, he could go to tests and see what is the expected output of certain functions. So it could just serve as documentation and knowledge sharing across the team. Okay, let's move to the next part, which is a function that encodes product type. So each product in the shop has a certain type. So it's either a veg, fruit, pastry, etc. And in machine learning pipelines, we we usually encode this type of categorical data because some of the algorithms can't process non-numeric data, and we're using ordinal encoder for that. So we're replacing the categorical values with numerical, starting from 0, etc. And if the value is unknown, we want to assign 999 to that category. But what does unknown value mean? In machine learning, we usually divide our training set, our data set into two sets. So there's a training set and a validation set. And the model is trained on the training set. And also all of the components of the model are trained on the training set, including the encoder. So we want to make sure that our model learns the categories from the training set to make it as realistic as possible, because we expect that in the future we will get some different categories that the model does not know, and we want to make sure that it can handle that. So we train our model, we train our encoder on the training set, and we transform the training values, but also the validation values. So let's start writing the test. So first we need to answer this question: what do we really want to test, and what is the purpose of this? So in this case, it would be great to test whether the labels are taken from the training set and not from the validation set. So in order to do that, we need to specify two data frames, one for training and one for validation. And we have our EN numbers. And because all of the tests work independently, we can use the EN numbers that are invalid in the other function, because the functions don't interact with each other. Okay. And then we have product type. And let's say we have fruit and veg. And we need to do the same for the validation set, but in order to find out whether our function uses the validation set for creating the labels, we need to change something. So we need to add an additional category that has not been seen in the training set. So in this case, pastry. Yeah, and now we can call the function. Okay, so we have train, validation, and the name of the column. And what we expect is the labels to be, okay, let's extract the labels first. And the same for validation. Okay, so we assume that the training labels will be something like 0, 0, and 1. And the validation labels should be 0, 1, and 999, right? Because we have this unknown category that the model should take care of. And let's see it now. And it fails. And we can see that the problem here is actually the 999 part. So we didn't actually get this value. We got a different value, which is 2. And let's go back to the function then and see what could go wrong. Could anyone spot the error in this function? Come on, I believe in you. Okay, it will be a sneak peek then. So we can see this fit transform method that is used for the training set and for the validation set. And this is not exactly what we wanted to have. We wanted to fit the encoder on the training set and then transform the values on the validation set and the training set as well. So we need to replace this part with only transform for the model to learn only from the training set. And let's see now how this behaves. Yep, and now it passed. So we got the expected 999 for the unknown category. So this is another very important thing about tests. So it helps you to debug your code much earlier than in the production phase. So in this case, it would be a silent error, so you wouldn't really see it in any way. But your model would predict probably over-optimistically, which makes your predictions unreliable and not accurate. So that's why unit tests for these types of functions are really important. And yep, and let's move to the last function, which does a couple of things. So it trains a model using cross-validation, then it calculates errors for each fold and returns an average metric. So just from the docstring and from the code, we can see that there's a lot going on in this function. And that's why it's hard to answer this question, what do we want to test here? Because there's so many things that it's hard to decide how to do that. But we can see that there are some pieces of code that are repeated across different folds. So this particular code is repeated for each fold that we pass. So in order for us to make it easier, we could refactor this function to make it more, to all of the functions to include just one functionality and not a lot of them. So let's write another function, which could be something like train single model. And this function could actually use all of this code. So we need to pass x, y, training index, test index, and model. And it could return the error, which is map in this case. Okay, so now we can see that we actually have one thing in this function, which is training, okay, a couple of things, but still a little less. So we have training and predicting and calculating the error. So we get only one value for this function. And now we could replace all of this code with what we got over here. So train single model, yeah, and pass all of these. Okay, so also writing unit tests help us to refactor our code and make it cleaner, because while deciding what to test and what to avoid, we do this spontaneous refactoring to make our life a little easier. And now we could move to testing this train single model function. So we can replace this import, this one too. So let's look at the function and decide what we want to test here. So we only got one output, which is which is a metric error. So we could test something like whether the error is larger or equal to 0, because this is something that we expect. So in order to do that, we need to create a data set, which has, 20 features, some samples, and let's say random state. Then we can call our function. Model in this case is random forest. And train index could be something like, okay. And the output is mappe. So the only assertion that we will have over here is that mappe is more or is equal or larger than 0. And let's see if this works. Yes, it worked. So refactoring in order to write cleaner code and to write cleaner tests as well is also to spot some errors that we haven't realized before. So in this case, we have this train single model function, which takes a model as an argument and then fits it and predicts. So if we were to clean this function even more, we could write code that checks if the model has been trained before or not. Because if it has been trained before, it still gives us results that are not reliable and accurate. Yep. And what we also, what we also would like to focus on is the test coverage. So in our case, we tested almost every function. We have this train RF and calculate CV metrics left, and we would probably test that as well because we want to make sure that a large amount of our code is covered by unit tests. Okay, so let's move back to the slides. So before I wrap up, I would like to leave you with a certain message, which is make testing a habit, because machine learning code is code as any other and should be tested as regular code. And it's fine if you don't test your code when you play with the data or are prototyping or doing your first run of a model. But before you actually generate the actual predictions, because before you serve them to the client, it's essential to test the code to make sure that you're producing reliable results. The other important thing is to anticipate what can go wrong. So don't only think what is the ideal scenario of your data and how the clean data should look like, but also what are the different possibilities if something goes wrong. And as I already mentioned, tests are part of your code base. So they should be updated and improved along with your code base. And the last very important message, don't end on unit tests. They are super important, but as I already mentioned, they work in isolation. So in order to make sure that all of your program works as expected, you need to also include integration tests in that, because some functions may work correctly, but when you combine them together, they kind of, as you see on the meme, they don't really make any sense. So, yeah, thanks so much. If you have any questions, then I'm happy to answer.